So yeah, start recording and let's start. So one minute. Yeah. So let us start with some variations of lattice counting. Okay, of counting paths on a grid. Okay, because that was the topic that we had sort of seen in detail. So let's do variations on that. Okay. Because usually in the texts, this is not present too much. Okay. So variations of path counting. Okay. Let us start with the problem right away. Okay. And then we can see how it connects with things we have done earlier and so on. Yep. So the problem is as follows. Let me just do it through the diagrams. You have a, let's use a black color. Yeah. So you have a grid. Okay. And you have some points on the grid. Let us take 5. 1, 2, 3, 4, 5. So once again, the question will be somewhat like finding the number of paths from one point to another, but the rules will be different. And I had done this in level 2, but I do not think I did it with you guys. But in any case, we'll see. 2, then this is 3. 4. Minute. Yeah. This time there will be 3 moves. Usually we had 2 moves. This time there will be 3 moves. That will be a difference. Sorry. So we have, okay. So this is the grid, okay? And obviously you understand that this point will be 5,5, and we have 0,0. So the moves are starting from 0,0. How many paths to 5,5? So this is similar. Till here it is similar, but given that each step is east, north, or northeast, one of the 3. So by north, I mean this, by east, obviously, and northeast. These 3 moves are allowed. Okay. And so how many different paths can you trace out is the question. And let me just give an example quickly. So you could take this, then you could take this, then you could decide to take this, 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 this. You see, so there are more possibilities now than the earlier very simple variation we had. I suppose that obviously we know how to do. Let's think about this. Okay. And today, the other guy has not joined. Unab has not joined. You can use you do not need to use all three. Obviously, you will need to use two of them with one move. Okay, with one move also you can go. You can just take northeast, northeast. Yes, certainly. That's why there are so many possibilities. So maybe with a different color. Yes, you're right. You can take a lighter. You can just take this path. So this is the shortest path, right? This will be the shortest path. Yeah. So do not, maybe just a suggestion. Do not think that there is just a formula that you can apply. Maybe there is no formula for this. That's why it's a very suitable question, because there is no. It's like someone, if is smart enough, can just do this without any prior theory or anything. This does not need any formula. Rather, I think there is no formula for this. There's no easy formula for this question. So you have to just do it by some technique of counting something. Just think about it, then we will say more. So any ideas? Yes. So the question is just to find the number of paths once again from 0, 0 to let's say 5, 5. But this time the moves are different. We have three moves. One is to the right, one is up, but one is diagonal also. So you could use a combination of them in any way. Just you have to just reach 5, 5. So how many different paths are possible? I have drawn two paths on the screen. Yes, so we are doing counting. The last time we were doing counting, we did a bit of path counting, and using that we did a bit of binomial coefficient kind of thing and so on. Today we are back to path counting proper. We just want to do some more variations. Okay. Yeah, so here is the problem. Okay. So let's say if you are finding 5, 5 difficult, you would have done for 1, 1. What is the answer for 1, 1? I'm calling it answer of 1, 1. This is a fair notation. You agree? Answer of 1, 1. What should this be? How many ways are there to go from 0, 0 to 1, 1? Given these three moves that we have. Absolutely right. Three ways. Does everybody agree to that? There are just three paths. I mean, you could just see it. Could draw them and see. Sorry. So there are just three ways. Right? This is, I will draw all three. So in this way, if you think, then can you build up? So let me just do one thing. Maybe this can help in further thinking. So I'm just doing it. What I will do is I'll replace 1 comma 1 from there and I'll just write 3 there. I just write a big 3 on top here. Now you know what that represents. I don't need to say. Right? And here I will write 1. Now you also know why I've written 1 there. And here also write a 1. And we have done this kind of problem earlier, but in a different kind of setting. So we'll do this and then see. So what number should I, so I'm circling something here, this coordinate 0, 2. What number should I put there? In this circle dot. So let's forget about 5, 5 for a second. What number should I put here in place of 0, 2 in this place that I've circled? That's perfect, right? Just a 1. So now you can understand all of this will be 1 because obviously there is only one way. And also these are all. Now, what number should I put here in this new circled dot, which is 1, 2? Why 4? So I'm just asking number of ways to go to 1, 2. Is it 4 or is it more than that? Yeah, others? So it is at least 4. That is fair enough. But is it more than 4? Remember, you can also move diagonally. You can also use the northeast step. Okay, why 6? What are those 6? Why 6? So certainly this one pink one is there. What is the other way? The other way would be to go like this. Yes, right? We can go like this. And what are the other ways? Yeah, northeast, north. And then there is this. So how many do we have? Yeah, northeast. Yeah, so that one was missing. Yes, that's right. North, then east, and then north. So we have 5. And so obviously there are 5, right? You can see there are no more. But this is just, I'm sorry. This is how a proper layman who does not think I does not think would just do 5. Meaning this is something that one can just count. This is simple. But can you say why it is 5 in a more interesting way? Or for the time being, we can just write 5 also. I'm not saying it is important that we find an interesting way, but soon we will have to, because we need to find this 5, 5. Okay. So I'll just write 5 here, but try to think of a better reason, maybe if you can, or maybe find some other dots, find these numbers here, what should be on those dots, and then you can use a pattern or something, up to you. So what should be this? And once again, you do not have to do it manually, just think. You don't have to manually go start right from the origin and do everything again. Last class we did symmetries. Is there any symmetry here? So can I say by symmetry that a2, 1 should also be 5? By symmetry. Obviously, I want someone to explain this. Just I'm using the word symmetry. You can also use the word symmetry and get away, but why? Like, what does it mean? What do I mean by symmetry here? Because you see, it's very simple. If you take any path from 0, 0 to 1, 2, if you take any path, just take this path. What you need to just do is you need to take the reflection of that path about this diagonal. Is that right? If you reflect that path about the diagonal, you get a path here. And vice versa, right? Any legal path you take from 0, 0 to 1, 2, you just need to reflect it. And you get a path here. So any path here corresponds to, can be matched with its reflection path that side, and so on, so on. Just maybe try to write it, okay? But it's very clear that this works. But don't just write the word byte symmetry and just be done with it. Try to write an explanation, proper explanation. Like I gave one explanation, right? Any path on this can be reflected to get a path of that kind from 0, 0 to 2, 1, and vice versa, so on. Okay, this symmetry concept is game changing. Okay, because sometimes it may be difficult to find an answer of something in some context, but when you take a reflection of that and see the same thing in a different context, then it may reveal the answer, but the answer will not change. And so you can use symmetry is can just change things completely. Something unpenetrable may become simple by using symmetry, and otherwise it may be impossible. Obviously, in this case, it's not a game changing, but it's we are starting to get this idea of symmetry is a fundamentally can be a fundamentally different idea. Yeah. So, any questions with the symmetry idea? The small ideas and small logical things is what can make the problem simple. Obviously, I could have just said a few words directly and given the answer, but I'm just trying to do this. Okay. So now do you guys see any pattern? Or, I mean, let's do one more, then maybe we can see. What about this? Suppose, so to ask yourself, right, I want to reach 2, 2. I already know how to reach 1, 2. I'm just using the word how to reach and how many ways to reach. How to reach 1, 1, how to reach 2, 1. Now I want to know how to reach 2, 2. How will you reach 2, 2? What are the possibilities? I mean, just don't carry the entire path with you. Just think, if I'm reaching 2 comma 2, then where could I have been in the next step, in the earlier step? Where could I have been in the earlier step? And then think. That's right. Oh, no, no, no. There, why a 5? See, already to 10 are there, right? See, if you reach this, there are 5 ways to reach here. And there are 5 other ways to reach here. They are different now, right? They are different. And so it's, so what if I say it's 13? Yes, why it's adding? That's all you have to explain now, right? It is adding up these 3, and why is it adding up the 3? Can anybody explain? Why is it 13? I mean, you can also verify it word by word. You can go from the origin, and that anybody can do, right? If you just spend enough time, you don't need any mathematical background for that. But why? But you have not said why we are adding. You have expanded on what has been said. I mean, you're just expanding on the fact that we are adding. But why are we adding? Why not multiply? Or why not add 5 and 5 and subtract the 3 or something? Why not? Why just simply add? Now it may be very obvious, but you have to still explain, right? I mean, I'm just saying this to all of us, of course, right? It might be obvious that you should add, but still you have to explain. So see, the explanation goes something like this, right? And again, I will not say it very clearly intentionally, because now I want you to write it and write it, show it to me, or if you are confident enough, you don't need to. But yeah, the explanation goes like this. Okay, see, any path from 0, 0 to 2, 2, I'll write a few things. Okay, if P is a path from 0, 0 to 2, 2, right? Then in the second last step, right? In the penultimate step, right? In the second last step, it would either be here, here, or here. You can say it like, then P passes through, right? Exactly one of 1, 2, 2, 1, and 2, 2. You agree? No, not 2, 2, 1, 1. Sorry, right? It has to pass through exactly one of these. Any path has to pass through exactly one of. That's just completely obvious. You tell it to anyone. I just see it, right? It has to pass through one of these 3, right? And then you can write, if it passes through 1, 2, then there are 5 such ways, right? If it passes through 2, 1, 5 such ways again, 2, 2, 30, sorry, 1, 1, 3 ways, and so, right? And so total number of paths would be just summing it up, right? Because that's exactly what we are doing, right? Any path is of one of these 3 kinds, right? So total number of paths would be adding one of these 3 kinds. And they're all different. Any path that passes exactly one of them. So they will be different paths. Is the argument okay? If it's not okay, please say. I'll try to say it in a different way. I'll repeat. Like, please don't just leave it. I'll add it when the problem comes. I'll just add it in the exam. Who cares? But no, because there's a side variation again here which can be given. You'll be lost, or you might make an error. So understand that you have understood or not. Try to understand, or try to find find a find a fault in it or something like that, and then yeah, try to affirm it after that. Okay, so it's okay. Is the reasoning okay? All right, then it's good. Okay, okay, but still you have to still write it. Okay, because when you try to write it, you will see you might get stuck in few places. Oh, is this correct? And this part or that part. It's very important to write. Unless you write, you will not learn to write. There's no other way. So this is the reasoning. So you see, this has many names. This is called recursive thinking. You're trying to find something using smaller values, right? You're essentially trying to explore how this structure is growing, right? You're understanding the structure by studying its growth rate, by studying how it is growing, and it is growing by adding the previous three, right? So understanding something using the way it is growing is the heart of what differentiation is, or its discrete version is recurrence relation is, something that some pattern that keeps recurring. Okay, some pattern that is based on its previous smaller values. So differential equations, recurrence relations, differentiation calculus, velocity, rate of whatever, all of it is just, one is the discrete side, one is the continuous side, but they all have the same fundamental thing. Some process may be very difficult to understand, like directly understanding the paths from here to here is very difficult. But if you understand how these set of numbers are growing, then it becomes suddenly easy, right? Like this would become 7. Now you can just quickly fill it up. You can do that faster than me, right? Just you can fill it up and you can find it. Won't take much time. But you see, there is no formula. At least we don't know. Might be. Okay. You can also write, now this is slightly abstract point. So see, try to understand this. We can also write this general thing. If you want to reach n comma m, right, then that is just the number of ways in which you reach n comma m minus 1, right? Let's say n comma m. Then you see here, here, or here. You know what those points are, right? These are these things. This. You see this. This is the way it's growing. Now, can this be solved to find a formula for n and m? Because see, this is not a formula. What is a formula? What is a formula? What is a formula? What should a formula be? A formula should be that it should be a direct answer, like maybe 2 to the power n plus 5 to the power m by something, but it should be directly. Directly, I put in n and m, I get the answer by some simple arithmetic calculations like multiplication, addition, division, power, and so on. But that is not how this is, at least, right? At least that's what we know till for so on. So for now. Okay. Now it is possible to solve these things, but the answers are pretty complicated. And that requires some more like if you try to solve this, you'll see it's very difficult. You maybe, yeah, if you're not, this is a 2 variable recurrence, it's pretty difficult to solve. But in most exams you will writing, or it's, you will see that it is not, never you will need to actually solve it. Okay, they'll never ask that. Okay? That's an advanced thing. That's not a conceptually deep thing. Okay, so that's not for now. Okay, but later on we can use these things to, or you can use these things to learn how to solve. Sometimes you will need to solve. Okay, so that was the first variation that I wanted to do. There was a brick problem that we had done earlier that was also similar, right? Okay, so please find the final answer. Obviously for 5,5 in general, you cannot find directly. That's what we know so far. Okay, so that was the first variation. Let's do one more variation. Maybe I should have kept the path. Anyways, doesn't matter. Okay. Now we will change the moves further. change the moves more and ask the question. This time the moves will be northeast and southeast. Okay. This time moves will be northeast and southeast, not north or east. So we cannot move directly north or directly east. Now this is also I had done in level 2 with the other guys. Obviously there we went a bit fast. But here we will go a little slow and understand this better. So you can already start thinking maybe. So we are trying to only take the northeast move or the southeast move. Okay, and once again, we want to, let's say, go from 0, 0 to, let's say, 9, 0. Yeah, it's it's slanted up. Try to. Maybe if I use a better whiteboard, like some sort of an app, then these things can be done better. Maybe I'll try to do that next time, especially when if I'm doing geometry, then it will be very helpful. Anyways, yeah, the real meat of the matter is in understanding these things. Okay, so the question is again, it's clear. I'll just write it very short. Okay, so number of paths from 0, 0 to 9, 0 using only diagonal moves, only northeast or southeast. Yeah, so once again, I had done this in level 2. So those who were there maybe would know, or who have watched on the YouTube thing, I posted everything, would know, but still, even then we will do it. So first of all, can anybody give an example of such a path? An example somehow. You can, obviously you can't take this. This is no move, right? That's not allowed. You can take this, and maybe you can come down and so on. You can reach, right? Da, 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 da. Can anybody give a concrete, or on a paper you can try to draw or think a concrete example? Okay. If you go 4 times northeast, then you'll go outside. You have to reach 9, 0. Okay, 3. Oh, but no. But you have to reach 9, 0. Remember, you have to come down. That is the question. Yeah. So it's this is a perfect answer if I would have asked 9, something. Okay. So you're saying from here only, from here, or sorry. The question is, I have, this is 8, 0. No, I was asking, so I have drawn it wrong. For 9, 0, I will have to make one more. Yeah, so that is a perfect answer for 8, 0. But how would you extend? This particular path that you said will not work, so you have to modify it maybe. Yeah, so I'll just say, can just say it again. So yeah, this is 9, 0. That was. Okay. So likewise, anyone can say a concrete path. So just like Shana was saying, like with not this move, yeah. So like that, some concrete path I am looking for an example. From here, okay. Yeah. No, but you cannot, but you will not reach 9,0. And remember, you are also allowed to go down and come up, but you cannot go horizontally. So no examples? Anyone has found example, or what is going on? I mean, what is going on in this picture? What is happening? Like, is there an example, or do we have some different answer, like underwhelming? Yeah, let's think. You see, if there was an example, you guys would have found it by now, isn't it? It should not be very difficult, right? I mean, if there is one example, there will be many examples viewing symmetries and reflections and so on, right? Or show that is not possible, or the basically answer is zero. No path exists. Hmm? Is it? You have to tell me. I don't know if you can find an example, or if it's zero, then why do you think it is zero? Oh, basically, why do you show? Okay, should be zero. So now everyone is tending to. Okay. Uno, what do you think? Do you think there should be a path, or do you feel like I'm not asking for a proof, right? But that there is no path? Which side are you inclined? Suppose you have to answer. Suppose there were two options and you have to, like, there is no negative marking or anything of effective that nature. What would you say? Because that's important, right? There's no path. Okay. So all of us think that there is. So you said no path, right? Did I hear it right? Oh, sorry. Okay. So you think there is a path. Okay. Okay. How do we make it? Okay, then try to find it. And if someone can find an explanation as to why there is no path, then also it is. Because see, if there was a path, it would be not so hard to find it in this picture, right? Because it's in front of us. I mean, yeah, that's not a very good statement, but what is a rectangle shape? Oh, no. Okay. No, but you have all dots available to you. So feel free to use any more dots if you want. So I'm not stopping you there. Yeah, that is certainly a good answer. Yeah, if they don't give you these things, then you can say, yeah, that is not enough space. Maybe you can give some reasoning like that. But but my question is more mathematical, if I may say. Like, you have all the dots available to you. Obviously, you won't need much after a certain point. Like you won't need to go beyond 9,9 certainly. Means you can't even go that far. But yeah, everything is available to you. All dots are available. Even then, yeah. Hmm. Hmm. Yeah, that is the reason. That is essentially the reason, right? It's not totally complete. Like I'm not totally. You have to write it still. There is still something missing, I feel. But yeah, essentially the thing is, and you would like if you're caught in this no path or path, just try to take smaller examples, right? Try to take 1 comma 0, 2 comma 0, 3 comma 0, 4 comma 0. Then all the doubts, at least you would know what is the truth, right? You may not still have a proof, but you would be sure. So always small cases have a lot of power because maths is we are trying to find patterns in things, right? So small cases is what we show you. But yeah, exactly. So what Pragya has said is the right is more or less the right reasoning. But again, I will just say it in a different way. But again, I want you guys to write it. Obviously, if it's not clear, if it is not clear, you would say. So let me just say it. So yes, the point is that to reach 9 comma 0, you need equal number of northeast and southeast moves. That is the crux of the thing. Okay, that equal number of northeast and southeast moves are needed. This is the main thing. Okay, are needed. But the point is that every time you, but this is also has to be said, every time you make a northeast move, you are moving one step to the right. Right? So if you take X northeast moves and X southeast moves, then you would make 2X total number of moves. And that means you would move 2X steps in the right direction. Is that right? Because every northeast moves means one step to the right. And every southeast moves also means one step to the right. That is the kind of problem that we are in. Right? So you would end up in 2X. That's all. So you have to, it's just like that. But write it. Okay. But more importantly, if you have not understood, please say. Okay, so it's clear, right? So this is the thing. You see, these are variations. You can have answer. You may not have. You may have zero answer also. Okay, so be careful of these things. So we are doing this like a game, but these are mathematically fundamental questions. These lead to some very deep questions about you know, geometry of things and number of sequences with some property, and again those count some very important things, and then it's related with some good maths and probability theory and all kinds of things are there. Okay, but we are just touching the surface. Okay, so yeah, no path exists. So that was a flavor in the kind of this kind of things that can happen. Okay, yeah. You have to just ask yourself, okay, if a path existed, then it would need how many northeast moves, how many southeast moves, and should be equal, and so on. So okay, now let's do a variation where we know that the answer is true. So let's do actual combinatorics, actual enumerative combinatorics. What we just did was more like existential combinatorics, right? That's obviously this is also an important branch, showing that certain structures don't exist, right? Forbidden structures. Yeah. So here we have 8 comma 0, let's say. Yeah. Now let's come back to the good old question and try to see how do we count. And you, what we have done so far will be can be useful. So I'll just remove this topic. I'll deep into it. Yeah. And just one request, please check your mails. Okay. Because I don't use WhatsApp and I am being a bit inconsistent, changing times and so on. So maybe just once a day, take a minute and just check your mail. Okay. Don't miss it. Yeah. I'll still try to do it through WhatsApp, but sometimes I don't open WhatsApp for long hours. So I sometimes don't. Yeah. And it's a good habit. It's a very important habit because you can understand all things are happening over mail. But not too often, just check once a day, and just that should be enough. Because I'll usually send it at least 24 hours before. Obviously, checking mails is also a very draining thing, but for me, WhatsApp is more draining because it's always at you. Yeah. Exactly. Yeah. So for any such path, we will need fourth now, and this is obviously clear, right? Because the equal number has been already set, right? Yeah. So fourth northeast steps and four southeast steps. Okay, so that's I think the most important observation. And then what? Any path from 0, 0 to 8, 0 will be like this. Will need this. So once again, you can see a similarity, right? You can see a similarity with the original question we had. This is how we had reduced it, right? We had said that if you want to reach 8, 8, 8, 8, you would need 4 north moves and 4 east moves, something like that we had said, right? Or I don't know, 8 north moves and 8 east moves. And that number was the key. Then we converted the problem to a sequence problem, sequence with 4 N's and 4 S's, something like that. We counted it. That would be the flavor again, because we know how many of what is needed. Yes, right. It is 8 factorial by 4 factorial into 4. That's what we also call 8 choose 4. Just a name we give to it. So does everybody see why that is the case? Yeah. Because one thing has to also be said that so you have to also say this, okay? If you are doing this, and if you're writing it, if you have to write it, then you have to say this, that see, for every path from 0, 0 to 8, 0, certainly you need this. But you have to also say that if I take 4 northeast steps and 4 southeast steps in any order, then where will I end up? At 8, 0, right? So 4 northeast steps and 4 southeast steps taken in any order, yeah, would land up at 8, 0. Because there's no other place you can land up, right? You will land up at 8, 0. 0 because equal number of things, and 8 because total is. Okay, so that has to be said, right? And every path will give a unique sequence. So northeast, just let's call this NE, let's call this SE, right? So every path will give a unique sequence of 4 N's and 4 S's. And that we already know what the answer to that is, right? If you are not confident about why that is this thing, or 8 choose 4, then please do ask me. We have seen that, so I'm assuming. Like for example, this, what sequence will this correspond to? Like from here, what sequence will we get for this particular path? Yeah, anyone? I just want to give an example. Suppose, yeah, you should be able to execute this correspondence from a path to a sequence. Okay. So, but you guys understand, right? Every path will be composed of some northeast steps and some southeast steps, right? So given a path that will give you a sequence of northeast and southeast steps, what sequence will you get for this particular path? Right? Yes, right? So just simple, that's right. You get this, and then again northeast. You have to just basically write in short form what we say in full, to northeast, to simple, right? And that's it. That's all this question is about. Okay, this can also be done directly by rotating by 45 degrees and so on. If you rotate this thing by this structure by 45 degrees, not just rotate, but you have to do a bit more, rotate and expand a little bit. But roughly speaking, if you rotate, this particular path, roughly speaking, that's not true, will get converted to something like this. Like this diagonal move will become like this diagonal move will become like this, and this move that is southeast would actually become east, right? If you just rotate this entire figure, right? Roughly speaking, though the length will not be preserved, so but the combinatories will not change. This would be transformed to this, and so on, right? You can see where you will end up. Okay. somewhere here, maybe 4,4. You can call that 4,4. Okay. These ideas of rotations and all will become crucial later on when we ask harder versions of this. Okay. But for now, it's okay to keep this. Another variation which I am asking, but we'll not discuss it now because in some sense it's, yeah, let's not say anything. I'll just say the question and you guys should try it out later on. So see, we are just, so I think the most important thing you could take away from here, these questions are, just natural, just starting with a basic question, we're just taking simple variations, just something that a bunch of curious people would ask. 10 different people would ask 10 different questions and some of them would be like this, right? And then we're just trying to answer them. So it's just all internally motivated, in the sense that it's just, puzzles and the main variations that you just make for yourself and challenge yourself with. It's just like that. So I would encourage you people, maybe this is it's interesting that you can do, come up with other variations. So each of you maybe can come up with one more variation. Okay. Come up with these are actually, so it's like you're doing maths in whatever small or good big way, but you're doing maths, not just reading maths and solving problems, but actually doing maths, right? Obviously now you're not just reading maths, you're also trying to appreciate a statue, appreciate maths, but also doing maths it has its own um, enjoyment, right? So come up with some variations and with their solutions also, maybe, because if you just ask a variation which is completely hard, like just a very random thing you can ask, right? Then there will, okay, so come up with a variation that is, natural, something natural and something fun, and maybe answer it also. Okay, so come up with variations, natural variations, and maybe also some maybe solutions, but the variation should be just the natural thing, some change in moves or something like that. Okay, just see and you will see how rich this subject is. Okay, to actually do, come up with it, write it, just start doing things, right? It's very fun. So this, yeah, but this will not be very helpful for exam perspective, but just I'm saying in general. Okay, so yeah, whatever, right, please do this. Okay, please come up with some variations and write it and show it to me, send it. Really very fun. Okay, but the variation that I'm going to give now is just a very simple one. It is northeast, southeast, or east. That's all. Note it down and try this. Now you're allowed to go east also. Okay, so you can take like this and you can go down and you can take this. Okay. Think about, think about it. Wait, maybe just give me 1 minute. So if I'm taking 1 second, just 1 second now. Is this, obviously this is also a question that you can think about, but I want to give something which is connected with what we have done. So if I make one northeast move and I rotate, it becomes, make one southeast move, that becomes east. This move, 1 minute. So this move would become, sorry, 1 minute. So So take is not one east move, but two east moves. So you can so you're not allowed to make one east move at once. You can ask that question and do all that also, but that is much more difficult. That probably you cannot do. Okay, means it will be suddenly very difficult. I think that's also a question, but that is very difficult. That was yeah. Just answer this question. Okay, so you are allowed to make one northeast move, one southeast move, or two east moves. So I did some calculations using vectors, and I came up and I maybe recalled it through this. Okay, but that is not for now. Later on, you can use that machinery. But yeah, think about this. Okay, I just give you an example. So again, so I'm only allowing two east moves at once. So you can do like this. You can sleep for first 2 minutes and then wake up. Then again, energy level goes down and you reach. This is the thing. You are not allowed to do this and then at an odd thing you just rise up. That's not allowed. Okay? And then you do this and you know this is not allowed. When you're making an east move, you have to make two east moves at a time. Is the question clear? Okay. There was some simpler variation of this in one of the AME question. This is a standard question. This is not, maybe it was there in some Olympiad, some lazy Olympiad where they didn't try to make a new question. So yeah. So please note down the question. And I just want to say that the first question we did today has a name. Those are called, okay, it's gone. Not important. Those are called Delaunay paths. I think, I don't know if I'm pronouncing it correctly. The first question that we are done. Okay, where we were asking, where we allowed north move, east move, and northeast moves. So those paths are called Delaunay paths. Okay, they have an importance in many other things, in tilings and so on. But for that we'll have to understand, have better sense of reasoning about symmetries to see the connections. So we did some things about paths today, simple things. And we have slowly gone into a little bit of recurrence, building answer from smaller answers. So then let me ask a question about which is related to this building of building from smaller, right? Building answer from smaller cases. Yeah, just this last one, okay? Because I don't want to do another, because the next topic I plan to do was about, because we had also seen these balls and boxes, right? We had kind of introduced that. We had seen its connections also with path counting. So I wanted to do various variations of balls and boxes problems. But let's just devote one class to that in the coming week. I'll take a class during the week also, hopefully. So we'll see it there. But I just want to, again, because the idea of building from smaller ones, it can, you already saw it, it can be game changing in the sense that it suddenly gave us the answer so quickly, right? You could fill in the numbers so quickly using the smaller cases once you saw the way things was growing. So a simpler version of that question is this. So I'll ask this: building from smaller cases. Basically, this is a topic of reconciliations is a big topic, and if you open any Olympiad combinatorics book or any combinatorics book, it will have recurrence. It has to have recurrences. I mean, a general combinatorics book. Okay. Obviously, there are books only on recurrences, but that's there for everything. Yeah. So yeah, so the question is this. So suppose so yeah, I can just ask it. So this is the one-dimensional, I'm just putting it like a one-dimensional problem, okay? Maybe you'll never find it in this form. It's usually asked in a different way, but let's just experimenting with this. So we have this one-dimensional grid, okay? One-dimensional grid. Okay. Yeah. So you want to start from here, which is let's say 0, 0, and 12, 0, 12, 0. What now? What moves can I give? Right. So here we are not interested in paths, but we are interested in the entire journey. Okay. So I'll say number of journeys. Journey would also mean where you got stuck and where you're moving, something like that. Okay. I mean, yeah, number of journeys. Just using the word. Should be I, yes, but never mind. Okay. Number of journeys from, let's say 0, 0 to 12, 0. Okay. Such that each step is either, now I could put this in a more colorful way also. You can take a bus always takes 2 steps, car always, or you can walk, you always walk 1 step, something like that from, but yeah, each step is either um, uh, each step is either covers 2 intervals, or you can take a grasshopper jumping either twice or either with 2 or 1 jump. Okay. Yeah. Each step is either two either covers 2 intervals, either covers 2 intervals or 1 interval. Okay. How many journeys? Yeah, that's, I've already written that. So an example is you can take like this. This is one journey. Okay. And another journey could be simply just to take 1 skips. And maybe just to speed withdraw a lot. Something like this. 2 different journeys, right? In this way, how many different journeys are there? I mean, this can be framed in many different ways. If I add a 2 to the power something summation, then it would correspond to how many different sums. Yeah, that would have been an interesting way to put it. That was a more elegant way. Anyways, I'll ask that later, and that will connect with. Just questions are coming to my mind now, random. I'm just creating randomly. So yeah, but let's do this one. Yeah, let's do this one first, then we can add a number theoretic flavor to it and ask a question. Set of 2 paths, meaning in what way? What is a whole path and what is a half path? Okay. Yeah, you have to break it up into smaller. That is true. Let's see. Hmm. Okay, yeah, one step path or right. Big path, small path, yeah. Or 1 unit. No, the big path covers 2 units. Hmm. Single unit. Okay, okay. Hmm. That sounds like some interesting reasoning. You have to. Hmm. Okay, a smaller answer if someone wants to give. How many journeys are there to 1, 2? Well, I'll just remove this second coordinate. It's pretty useless now, right? So just write a 0 and 12. So just write a 0 and a 12, right? So it becomes a linear thing. That's why it's a simpler problem. So what is A1? Just one. No, that's not the answer. The answer is actually again very hard. Okay. The answer is very, not hard, but very unexpected. But calculating for small cases is very easy, like for 12, 13. Like you can give a procedure which can be used by a machine or a computer which does not know anything beyond addition. Yeah, that's it's that simple process. But the final answer is pretty complicated. So anyways, help me here. What should be A2? You want to get here. How many different journeys are possible? How many different sequences of one steps? Absolutely, 2. Now what is A3? 3. Okay. What is A4? Is it 4 or is it something else? I mean, should it be 4 or should it be more? Just like the first problem we did. There are more, right? So what is it? Um, you can just quickly work it out and you will find it, right? Just just layer these up in any way you want. Just these arrows, right? Just layer, use them in any sequence you want. So you go down, then you go up, or whatever. You can just imagine all things. You'll see it's 5, and not more than that. Is everybody convinced that it is 5? You just work it out. Work it out, work it out. There's no rush. We should do this and should know it is 5. If anybody finds a 6th, then just tell me that's 5, right? Oh, okay, it's 5. Okay, let's do one more. What about this? And once again, you can either do it manually, brute force from the very beginning, or you can now start to use some sort of a, just using the smaller cases and building up. And yes, it is 8. Okay, so I'm not asking the reason now. Think of the reason, and that's it. Now, I think all of you see the pattern, right? It's just adding the previous 2 numbers. This is what you guys would have maybe seen Fibonacci numbers. And suddenly this is the answer here is Fibonacci numbers. It is just the previous 2, adding the previous 2, and just find the reason and write it. Okay, I'm not going to say it. but the pattern is this. And again, you have to find the reason and write it. Pattern is this. So this is the thing, but Fibonacci numbers you may have never thought of. Is there a formula? Or some of you may have seen or not seen, but if answer means the formula for n in terms of formula for the nth one in terms of n is pretty strange. It's nothing like incredibly hard or something. It is a pretty strange answer. Hmm? Yeah. Yes, that's right. And yes, yes. Yes, I mean one or two. So yeah, that's right. Because if you can reach this 12, if you are reaching the 12, you will either reach here, right? Or, yeah, if you reach here and if you want to keep, now you have to obviously write this properly, but if you want to keep them disjoint, then if you reach here, then you have to take a jump, right? I'm not, so if you reach here and take the small jump, a small step, then that doesn't count because that we will already consider that in this. Yeah, so now just think, I mean, let's not say it. You think and write. Okay. Right. So that's the thing. You see, this is a bit similar question to that, right? And suddenly it makes it so tractable. Ideally, this question should have been done first, but we are okay. We did the lattice things enough, so we understood that. The actual answer is this. It's a pretty strange answer. Not hard to prove, but hard to. So it is not something that is hard to prove. If I give you this as an exercise and do a class on induction, you can do it yourself. But what is hard about this is you would never think of this being true, right? So the point is like, it's like you don't understand why it is true, though you will know why it is true, right? There's a slight difference. Knowing why it is true is very simple using induction. You assume for n minus 1 and add the answer, you will get the answer because some sort of induction axiom you can use. But you would never think of this formula, right? This kind of formula. But soon you will once you see some more language building and so on. So this really is the, we have the energy now to start knowing how to solve this recurrence. But I'm not doing that because those are not on the highest priority case right now. So I'm not just delaying them, but certainly there is enough motivation to study them. Okay. But there are only so many things we can do. So yeah. Okay, so let us stop here. I think we did a lot of things. I will take one more class in this week. So I think the length is long enough. It gets